In this video, we are continuing our Quiz 5 review, and we'll talk about drawing conclusions from if-then statements. So we've seen this table before, but I want to review it, which says, in general, if we have an implication, P implies Q, and that is a true statement, and P is true, that means then that Q will also be true. If, on the other hand, P is false, well, then we can't draw any conclusion about Q. So then we are inconclusive about Q. Q could be true. It could be false. We don't know. If Q is false, then P is false. And that is the contrapositive. That is the contrapositive. And finally, when Q is true, we are inconclusive about P. We are inconclusive about P. P could be true, it could be false, we don't know. So for all of these, it's important that the implication that we start with, P implies Q, that be true. So let's look at an example. So this example says, let S be the proposition if X is greater than 6, then -1 is less than or equal to f of x is less than 2. Suppose S is true. Determine whether the following propositions follow logically from S. Okay, so there's a couple of things that I want to note about this. So the first is that S is an if-then statement. So I'm going to call the if portion P, and I'm going to call the then portion Q. And I also want to note something about this notation f of x and what that means. So this is going to be some algebra review. So usually with functions, x is the input. X represents the input of the function. And in this case, we're calling the function f. Alrighty, and f of x is the output. F of x is the output of the function. Now I'm going to write a dash, but we also call the output y. So we could write y equals f of x. And if we did, the proposition S would read like, when x is greater than 6, then -1 is less than or equal to y is less than 2. So that's what this proposition is saying. When the x value is greater than 6, then the y value is greater than or equal to -1 and less than 2. Let's look at part A. Part A says, can I logically now conclude that if f of x equals 3, then x is less than or equal to 6? So I want to begin by having you pause the video for 1 minute to try this question. 4, 3, 2, 1. Pause it and try this for a minute. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for a minute. So remember, the question said that S, this if-then statement, is true. So P implies Q is true. And then in part A, what we're given is the if portion. F of x equals 3. So since f of x equals 3, that means Q is saying f of x is greater than or equal to -1 and less than 2. That is false. Because 3 is outside of that range of values that f of x is allowed to take on here. Okay, and because Q is false, thus I can conclude that P is false. That was that contrapositive condition. Okay, so that P is false, which means, let's write down what that means. So P is saying x is greater than 6. And if that's false, that means x is less than or equal to 6, which means x is less than or equal to 6. And that is precisely what I wanted to conclude. X is less than or equal to 6. So this logically follows. Logically follows. So let's do one more part to this example. Part B, which says x is greater than 6 if f of x equals 1. So again, I want to have you pause it. Ooh, let's put this in red. I want to have you pause it first and try this for 1 minute on your own. That may not be enough time to finish the question, but that's okay. I mostly want you to be thinking about what are the key ideas? How do I begin? 4, 3, 2, 1, pause it and try it for a minute. Alrighty, so hopefully you've done that. Hopefully you paused it and tried it for a minute. So the first thing that we want to be super careful about is, notice that the word if is written in a different place. So this statement is actually saying if f of x equals 1, then x is greater than 6. So we want to be really careful about that. The wording is important. It's not saying if x is greater than 6, then f of x equals 1. That is really, really important. Okay, so again, our implication P implies Q at the beginning. Whoops, let me zoom it out. So our implication at the beginning of the problem, P implies Q, that is true. So then I got to think about what we're given here. And what we're given is that if f of x equals 1. So since f of x equals 1, what does that tell me about either P or Q? Well, it tells me Q is true. 1 is in the range of values that f of x can take on in the proposition Q. But when Q is true, we can't conclude anything about P. We can't conclude anything about P. So we can't say, that x is greater than 6, like this question is hoping that we'll be able to conclude. Okay, so as a result, let's zoom it in. As a result, this does not logically follow. And that is our answer.